So today the topic which I'm going to discuss is acid, bases and salts. So I'll just give you a glimpse of, before I go into the session, I'll just give you a glimpse of how the questions are generally asked in Olympiad. So in these exams, they are not similar to what you read in your CBSE or ICSE or state board pattern. So there will not be just some simple multiple choice or short answer, long answer questions. So there will be always a connection between the concepts and the questions will be asked. So this is one such question which I have taken just for you to have a glimpse of it. So there will be always an analysis of question which has to be done after you know the concept. So just knowing the concept and directly answering it won't be doing it, because we have to know on how to approach a question, which is what you will learn along with the concepts as you are attending these classes. Guys, here the question here is given. Yeah, I'll love it if you can give me the answers for this. So just giving the answer won't do. I'll need the explanation for it as well. The question here gives is stated as such that the Rahul stained his shirt with turmeric. When the stain comes in contact with a solution of X, the color of the stain changes to brick red. When it comes in touch with a solution of Y, the color again changes to yellow. So what is the solution X and what is the solution Y? How do you approach this question? We have 4 options here. As I said, the topic we are discussing today is acids, bases and salts. So what are the solutions given here and what is the question? In the question, it is given already that the stain in shirt is turmeric. So turmeric acts as an indicator. Okay, turmeric acts as an indicator, which you will be learning in this class. So there are options given here, which is a combination of acids or bases. So the color will change for turmeric when it is in contact with base. When it comes in contact with acid, the color will be yellow. The color will change when it comes in contact with base. The color will remain as yellow when it is in contact with acids. So looking at that, what will be the options here? We have the option soap solution, lemon juice, and vinegar is one other option, and sugar solution is another option. So soap solution, as we all know, can we call it as acid or base? How many of you guys know? Can we call it as acid or base? Yes, soap solution. Soap solution comes under base. Okay, so if base comes in contact with turmeric, there will be a change in color of turmeric to brick red. Okay, now lemon juice, in the other hand, contains citric acid. It is an acid. It is a very mild acid. So citric acid, when it comes into contact with turmeric, you will get the color yellow, right? So if the turmeric comes in contact with acid, it will remain yellow. And when the turmeric comes in contact with base, it will change the color. So because the turmeric is an indicator, right? So that means X is changing the color. So X has to be base, whereas Y is remaining as yellow. So Y has to be an acid. So looking at that, the option A is correct, because soap solution is a base and lemon juice is the acid. So this is a glimpse of okay. So looking at this, we know that the option is A. So this is just a glimpse of question on how you will get the question in Olympiads. Okay. So we'll do some, we'll look at some concepts and then we'll go back to the question solving. So that is how the class generally will be. I'll be discussing a concept and then we'll discuss some questions based on the topic. So here we have some images here. The first one is mouth, which has some plaque. Plaque will cause due to the buildup. So this is an example on how we face acids and bases in our everyday life. So in plaque, right? In plaque builds up because of acids. So in order to contraindicate it, what do we use every day in the morning? What is recommended to be used twice a day? What is recommended to be used twice a day for removing the plaque? For removing the bacteria in our mouth? That's right, toothpaste. The acids which build up in plaque, right? The acids which build up and cause plaque in mouth, the brown, the staining, all those, which is caused by the buildup of acids, can be removed by toothpaste because toothpaste contains base, right? And suppose an ant comes and stings you, or a bee sting, right? If suppose it comes and stings you, okay, it has acid. It has something called as formic acid. So what do you treat it with? What can you treat it with? If something is stinging you and it has an acid, so what should you go for it? What should you go for? Base or acid? How do you treat it? We can use a base. That's right. Because the sting contains acids, we can treat it with a base. Okay. So one such base which is used is baking soda. Also, the answer is correct. We can also use calamine lotion. The lactocalamine which you get, even that contains base. So that is why when you get some allergies or some bites, right, you apply calamine lotion so that we can contraindicate whatever is the acid present in our body which is causing the sting. Okay. Stomach. Why did I show stomach all of the here? We have mouth, we have ants. Why is there a stomach picture here? Why is there a stomach picture here? Acidity, that's right. We have acids in our stomach which help in digestion of food. We have acids which help in digestion of food, right? So we have the acid called as hydrochloric acid. So if we go on hunger for a long time, or we have some highly oily foods, that will increase the acid buildup in our stomach. It will increase the amount of acid than what is necessary. So then we will get all this acidity, burn, right? You get acidity and burn. In order to treat it, what do you use? You use base, which is antacid. So these are some of the example of acids and bases what you face in every day. Right? Every day, almost every day. The toothpaste is supposed to be every day, isn't it? So we use these. We contraindicate acids to bases or bases with acids because it neutralizes it. We will be looking at it in the further classes. So this is called as neutralization. We contraindicate acid and base because of something called as neutralization. Okay. So now coming back to what are acids, what are bases. The question was based on indicators, right? So that is what is going to be the focus of today's session. Okay. Acids. What are acids? We have different kinds of substances which have acids in them, right? So, but what are acids? If you have to tell to someone what is acid, what is base, how do you say? When we taste lemon, it tastes sour, isn't it? It tastes sour. That is because of the presence of acid. So the first thing what you say when we have to say whether the substance is an acid or a base is the taste, right? If it is sour, then we call it as acid. That word acid comes from a Latin word called as acere. Okay, acere, which means sour. So we have different kind of substances in and around us where acids are found. So if you look at this table, generally you get a long answer question saying, or a short answer question saying, give me the examples of acids which is found in our everyday life, right? So these questions can also be expected in multiple choice or in indicators. We'll be looking at those questions. So this is an example of acids which are found in our everyday life. So vinegar you use in your fried rice, isn't it? The vinegar which is used contains acetic acid. And sting, as I was saying earlier, contains formic acid. Whereas citrus fruits, oranges, lemons, citric acid. So now tell me guys, when you have hunger, I said there is an excess of acid buildup in your stomach. Okay. So if I have daily, if I increase the amount of citrus fruits, if I take in amount of citrus fruits every day, is it good for our health? If I take citrus fruit every day early in the morning, just ripe lemon inside, is it good for our body? Is it good for our stomach? Okay, people are saying no. Why is it no? Why no? Why no? Okay, so just saying the answer won't be sufficient always. There has to be an explanation. You puke. That's right. Because already acid is present in our body. So we either have to dilute the acid by taking a cup of warm water, right? Or we have to take in a base, right? We have to dilute it. So just having lemon every day will increase the amount of acid buildup inside your stomach, which will cause irritation or vomiting, right? So curd has lactic acid, right? Curd comes from lactic acid bacteria, lactobacillus. The bacteria which is present will release acids which help in curd formation. That is how curd forms, because of acid formation from the bacteria. Okay. So also you get all these decaying of foods occur, isn't it? You get molds, you get fungus, and we store it in fridge in order to reduce the microorganism decaying, isn't it? This decaying also occurs because of the presence of acids. The bacteria and fungus which grow, they release acids, causing the increased acid buildup, and thereby they decrease the food. Thereby they slowly they engorge the food, and thereby the food is decayed. So if we preserve it in the fridge, what happens is the microorganisms do not survive. They will not be able to grow as much, and there will not be release of acid, which cause the decay of food. That is what is happening. That is why we have to preserve our foods. We generally preserve these perishable foods in fridge. And then we have spinach. Spinach is a good source of oxalic acid. Okay, so that is why we are not supposed to take in an empty stomach. We are not supposed to take whichever of these substances. We are not supposed to take it in empty stomach because of excessive acid buildup. Okay, and citrus fruits, as I said, it has citric acid, and amla contains ascorbic acid. Also grapes, tamarind, they contain tartaric acid. So these are some of the example of acids which is found in our regular day life. Okay, and acids by taste are sour. Okay, we'll be looking at the properties of acids furthermore in our coming classes. This is just an introduction for acids and bases. Okay, bases on the other hand, they taste bitter. So and also soapy. So that is why all the soap solutions which you see in and around, right? The soap solutions, all the Harpic, right? Harpic contains some amount of acids. The soap, the Lysol, which will create the soapy form, contains a lot of base. Okay, that is why they are soapy in nature. So whichever is soapy or bitter, it is generally a base. Also blood in our body is slightly basic in nature, and also the saliva in mouth. Okay, tell me, why should the saliva in our mouth is basic? Can someone tell me how does it help? How does saliva in our mouth is basic, whereas the food in our stomach is acidic? Can someone tell me? Can someone just try to think? Saliva is basic, whereas the acid in our stomach, right? It is acidic, isn't it? Why? Why do we need? Doesn't just acid be sufficient? Yes, the majorly in all the fruits, majorly, it helps in breaking down food, it neutralizes, very good. Majorly in all the fruits and in all the food which we take in, they are mostly, if you look at the examples, mostly they will have acids in them. Okay, mild acids, very mild acids, but they have acids in them. The saliva which is present in our mouth, okay, is basic in order to contraindicate, in order to neutralize the acids which are present in the fruits, and it will help in breaking down so that we do not get much ulcers in our mouth. If you get excessively acidic, you start getting ulcers. That is what happens. The saliva neutralizes the acid which is present in the fruits. That is what happens. So in and around us, as we have acids in and around us, we have bases in and around us also. So we have something called as slaked lime or lime water. We have something called as slaked lime, which is calcium hydroxide, So this is generally used for when we use fertilizers, right? Excessive fertilizers, they release lot of acid into the soil. For growing plants, we use fertilizers, isn't it? If it is not organic, we use fertilizers. They excessively release acid, which causes the soil to be very acidic. So what happens is the crops over the point of time, they won't grow properly. So what the farmers do in that case is they put some slaked lime all over the soil and mix it to neutralize. This is one everyday example where you use the slaked lime. And we have window cleaners which have ammonium hydroxide, soap which contain potassium as well as sodium hydroxide, milk of magnesia. The antacid which you take when there is excessive acidity in the stomach contains magnesium hydroxide, which is also called as milk of magnesia. Okay, so now we know that also salts are present. We looked at acids and bases. Acids are sour, bases are bitter, and also soapy. And we have salts also which are neutral substances. They are not acidic, they are not basic, they are neutral. So the matchsticks contain salt. We have seawater which is full of salt. Okay, and also the bath salts also contain salts. which are neutral substances. They are not acidic, they are not basic. We'll be looking at the properties of salts, how salts are formed in our further coming classes. So, is it possible that I taste every single substance and say whether it is acidic or basic? Why do we need indicators, right? We can't taste each and every substance, whether to taste, whether it is sour, whether it is bitter, and taste it and say, oh, is it acidic? Is it basic? We found indicators because acids and bases are not as mild as containing in lemon, right? We have this hydrochloric acid, sulfuric acid. You people would have heard these terms, isn't it? Which are which are fuming, and when they touch the skin, they burn immediately. Your skin melts. Sulfuric acid melts your skin completely. So that is how strong acid can be. So you're not supposed to taste acids and bases and say whether they are, because it is mild, it was okay enough to taste, right? So that is why we have indicators. When you have very strong acids, very strong bases, they are not good to touch. So we have indicators which say whether it behaves as an acid or whether we have base. So the type of indicators can be natural, olfactory, or synthetic. Natural and synthetic, they are based on the color of substance. They give a change of color on whether it is acidic or basic. Whereas olfactory, on the other hand, okay, it will be based on the smell. As the name suggests, it will be based on the smell, olfactory. So coming to natural indicators, we have different types. We have turmeric, we have China rose. Yes, that's right. There are many options here. We have China rose, we have litmus. So we are going to look at what are the color changes, and we are going to look at the different kinds of questions which can be answered based on that. So as we were talking in the question, what is the yellow substance which is present in turmeric? What is the yellow substance which is present in the turmeric? What is the name of it? Why do you get that yellow color? Yes, why do you get that yellow color? Guys, yes, why do you get the yellow color in turmeric? Who knows? The substance which gives yellow color is called as curcumin. The substance which gives the yellow color is called as curcumin. Okay. So when a base attaches, right, when a base is stained on turmeric, it gives brownish red. And if acid comes in contact with turmeric, it will give the yellow. So I can always also convert the red stain to yellow by treating it with acid. So if suppose I'm treating turmeric with soap and then I'm adding in acid, okay, it will still remain yellow color. Okay, neutral substances do not change the yellow color of turmeric. So give me example of substances which will not change the color of turmeric. Give me some example of neutral substances. I just told you what the neutral substances are. Water, yes. Salt, yeah. Anything else? What about sugar? What about sugar? Would it change the color of turmeric? Sugar. Sugar also is a neutral substance. It's a carbohydrate. It will not change the color. So that is an example of neutral substance. So how will it change? So we have a lemon juice and bleach. So if I put in acid, what will be the color? What will be the color if I put in turmeric into these two? For lemon juice and bleach water. Bleach is basic. Lemon juice is acidic. So if I put turmeric into these two solutions, what will be the color change? What will be the color change when I put in turmeric into these glasses? Bleach will be brownish red, that's right, and lemon juice will remain yellow. So the lemon juice will be, so you can also think it as mango juice, such yellow in color. It will remain yellow and the bleach will become brownish red in color. So based on the amount of base which is present, the color red will be that prominent. It depends upon the amount of base, okay, and also the strength of base, which you will be looking at. Next, the first one natural indicator was turmeric. The next indicator is China rose. So you guys, how many of you guys recognize these rose? China rose. How many of you guys recognize this? We have some other name in India. What is the name of this China rose? Anyone know? Bleach is harpic. All these substances is bleach. It will contain excessive hydroxides. Hibiscus, Gudal, that's correct. right? Hibiscus, that is what we call here, isn't it? So that is the example, that is China rose, okay? It can also be used as an indicator. The petals of it will be used as indicator. When just present in water, it will be light pink in color. When just present in water, it will be light pink in color. So if I add salt or sugar, it will still remain light pink in color. But if it comes in contact with base, it will become green. And if it comes in contact with acid, it will become this pink magenta kind of color. So with acid, it will become pink in color, that is magenta in color. With base, it will become this green in color. So now tell me, lemon juice will give which color? Lemon juice will give which color? Pink or green? Lemon juice. What about lime water? What about lime water? Guys, remember, lime water is different, lemon juice is different. Lime water is another name for calcium hydroxide. So if you hear the term hydroxide, immediately you have to jump to base, right? So lime water is calcium hydroxide. So it will give green color. What if I put in salt solution? What will be the color? What if I put in salt solution? Salt solution. What will be the color? What will be the color if I put in salt solution? It will be pink in color, light pink in color. I have said that in the third line. See, China rose indicator remains light pink in neutral medium. It will remain light pink. So the next indicator is litmus. So we look at water acids, water bases, water salts, and we have the three types of indicators: natural, olfactory, synthetic. Natural is turmeric, China rose. The third one is litmus. This is a dye which is extracted from the flowers, lichens, okay? And it has rich purple color. So in acid, it will give red color, and in base, it will give blue color. So if you see here, litmus can be in solution, which will give red color or blue color. And it is also available in terms of paper. So this is what we use in labs. This is what we use in labs, litmus paper. We take a litmus paper, we dip in the substance. So if I see a black looking substance which looks like water, if I find it in lab, I'm immediately not supposed to use it and put in some reaction, because it can be acid, it can be a base also. Just by looking at it, I won't be able to determine it. So what I'll do, I just take a litmus paper, dip in and see whether it is giving red color or blue color. If it is giving red color, that means it is an acid. If it is giving blue color, then it is a base. So if I dip it in water, what color will it give? What color will the litmus paper be? If I dip in just in plain water, I'm trying to differentiate water, acid and base. What is my substance in the beaker? Okay. It will not give any color. It will just become wet. The paper will be gone waste. It will just become wet. No use, right? So if it comes in contact with acid, red color. If it comes in contact with base, blue color. And if it is no changes, just becoming wet, then it is neutral. That is, it can be water, but it can be salt water also, isn't it? So never keep your beakers just like that, right? So we have some other examples of natural also. Most of you might or might not have heard about it. So one is hydrangea, which is a flower, okay? So this is really cool. So if it grows in acidic soil, right? Acidic soil where you have used excessive of fertilizers, it will become blue in color. Okay, if the soil is alkaline, it will give nice pink flowers like this. This is an example of flower which naturally blooms from acidic and basic soil and gives different colored flowers. Okay, we also have something called as red cabbage. Red cabbage. The regular cabbage, what you see, the lettuce which you see is yellowish white in color, isn't it? So there is also a red cabbage which is available, which will give you different colors based on the amount of acid or base present in it, right? So if you see here, the sugar solution is blue in color, right? The bleach is giving deep yellow color. Lemon juice is giving nice red color. Sprite is giving pink color. Why is Sprite giving pink color, guys? Why is Sprite giving pink color? Why Sprite acid? Yes. There are, what kind of acid is present in Sprite? What kind of acid is present in all these fizzy drinks, soda drinks? What kind of acid is present? Carbonic acids. That's right, Anuradha. Carbonic acid. Carbonic acid is present. So even if I put Coke, Fanta, Miranda, whatever I put, fizzy drink, whichever I put it in there, if it contains acid, right, it will give me that pink color. Correct? If I put mango juice, what color will it give? If I put mango juice, what color can it give? Will it give yellow color, green color, pink or red? Mango juice. It can be pink or red depending upon the acidity of the mango. As it ripens, the acidity will reduce. So that is why the sourness in mango is very, very high when you taste it when it is unripened. The green color mango which you take, right? It is very sour, isn't it? But as the mango ripens, the sourness decreases. So we can check also the ripeness of mango by testing with cabbage juice. How cool is that, right? Chemistry is cool, isn't it? So we have a different range of colors when we treat it with different. So that's the question asked, what color will it give in neutral soil? Okay, having neutral soil is very, very difficult, right? It will be an intermediate color. Whitish pink in color is what you get for hydrangea. I don't have the image there. Okay, but generally the soils which you find will mostly be acidic, rarely basic. If we use it repeatedly, it will generally become acidic because there is a lot of microorganisms present inside the soil which will release acids. We have ants, we have a lot of microorganisms. Most of the microorganisms, they thrive in acidic medium. Okay, they thrive in acidic medium, but it should not be too acidic also. That is why we add in salts or citric acid in order to preserve the pickles, right? So we preserve the pickles by adding in salt because we reduce the content. Okay, the next kind of indicator is olfactory. We looked at natural indicators. So they are turmeric, hydrangea, China rose. What else? What else did we see? Litmus, red cabbage juice. Olfactory substances are also natural, right? But based on smell, we differentiate it. The major examples what you can find in your household is onion and vanilla extract. Okay, so if you put in an onion in lemon juice, the smell will still be there. But if I put in the onion in bleach, in toothpaste, the smell will be lost. Similarly, for vanilla extract, it will retain its smell in acid, but lose its smell when it comes in contact with base. Okay, so vanilla extract, onion are the olfactory indicators which are available. Okay, the next is synthetic. Okay, so the natural indicator what we generally use in lab is just litmus paper. But because that is not sufficient, we have created some synthetic indicators as well. The synthetic indicators generally used are methyl orange and phenolphthalein. Methyl orange and phenolphthalein. Methyl orange, as the name suggests, okay, so do not get confused based on the name. Okay, methyl orange will give yellow color in basic and pink color in acidic. Now tell me, if I have ant sting, okay, if I squeezed off the sting of whatever substance is present in acid, which is present in ant, and take it and use the indicator methyl orange, what color will it give? The ant sting. What color will it give? What color will the ant sting? Whatever the substance which is responsible for ant sting give when I treat it with methyl orange. Pink in color. If I treat it with base, that is, if I treat it with toothpaste, it will give yellow in color. Phenolphthalein on the other hand, okay, neutral. If you see this image, the first one is containing acid. The first image is containing acid. The second beaker, conical flask, is containing phenolphthalein, neutral solution. The third one is containing base. So as I increase the amount of acid, the pink color will become really high. Is it clear? If I increase the amount of acid, the more pink it will come. If I have to bring it back to its normal color, I'll just add in the acid. So these are the indicators what you generally see, okay, which is generally used. So this is just a compilation of whatever we have read. Natural indicators, which is litmus, red cabbage, flower of hydrangea plant, and turmeric. Synthetic, phenolphthalein, and methyl orange. Olfactory, it is onion, vanilla essence, and also clove oil. Clove oil can also be used, which will give the smell in acidic and lose its smell in basic, similar to other olfactory indicators such as onion or vanilla. Methyl orange will be red in acidic and yellow in basic. Okay. Now, with the questions. Okay. Who is excited to try the questions now? You know a bit of indicators now? We read natural, synthetic, and olfactory. So there will be some questions on how it's going to be discussed is what we are going to see here. So look at the column. First question, match the column 1 to 2. Who can give me the answer for this? Guys, come on. You have an option here. A, with different kind of substances. B, whether they are acidic, neutral, or basic, or indicator. Can you give me, can you guess what is ABCD? This is such a simple question. We have vinegar, we have milk of magnesia, we have sugar solution, and we have Google petals. What is the answer for this? Vinegar is acidic. That's right, isn't it? So it can be A, C, or B. Milk of magnesia, as I said, is magnesium hydroxide. So it is basic. That's right. It is O. Sugar solution, on the other hand, can be, sugar solution did not change color when it came in contact with turmeric, isn't it? So it is neutral, isn't it? So the option, by then I know that it is option B. So obviously D is going to be 3. Google petals, China rose acts as an indicator. Correct? Next question. Niranjan collected soil samples from different fields which have poor fertility. He collected the following information about 2 fields. Excessive use of chemical fertilizers in field 1. Soil solution of field 2 turned color of phenolphthalein to pink. Suggest the soil treatment for 2 fields for better crop yield. So what happens when you use excessive chemical fertilizers? Yes, what are the options? A, B, C, D. Okay, just giving the options won't be sufficient. You have to give me the explanation. You have to give me the explanation. Just give me the option won't be sufficient. You have to tell the reason why. Otherwise, what's the use, right? What is the use of teaching so much? Yeah, so excessive use of fertilizers causes the field 1 to become acidic. So if it becomes excessively acidic, in order to neutralize, I can use lime water or slaked lime, right? Field 2, the phenolphthalein is changing to pink in color. That means there is increased base in the second soil in field 2. So I have to treat it with acid. So I can use some organic fertilizers, isn't it? So the option would be C, slaked lime for field 1, organic matter for field 2 to decrease the acid in the field 1 and to decrease the amount of base in field 2. Correct? That's right. Most of you got it first, right? Okay, the next question. Smita applied turmeric paste on thin stripes of paper. After drying, she put a few drops of given sample on this strips. She has a turmeric paper and she put some amount of sample solution. So she used amla juice, lime water, common salt, and baking soda. What will be the colors? What will be the colors which will appear on the turmeric paper when these substances are used on turmeric paper? Yes, guys. What? Okay, again, there should be explanation along with your answer. There should be explanation along with your answer. Always. Okay, that is when you learn more. Yes, it's D. Yeah, why? Because amla juice contains, it's D. Is it correct? Amla juice contains acid. So it will turn yellow. That's right, Devesh. What about lime water? Is lime water acidic or basic? I just discussed this. Lime water. It is not lemon. Lemon is not the term which is given here. I use the term lime water. Lime water is calcium hydroxide. See, I was saying this, right? Calcium hydroxide is lime water. So it is basic. Basic will give red in color. Correct? So yellow, red, common salt will remain neutral. So it will just be yellow. Baking soda will be basic or acidic. Basic or acidic. Basic or acidic. Baking soda. It is basic. That is why you apply on the strings, isn't it? So it will be red in color. So this is how you get the questions. You have to. So even this question has been, this is the final question. So even this question was given in the assignment. So this is how you get the questions. Whoever have any queries can type it in the chat. So we have different kinds of indicators which are used, and there are different kind of color changes. What are the color changes which will occur? Phenolphthalein, colorless to P. When acid is treated, to different kind of indicators, these are the color changes. So what can happen? What can happen? What are the color changes which can happen? Phenolphthalein, colorless to phenolphthalein on treating with acid. What will happen? What will happen? Phenolphthalein. It will become colorless, right? How come no one is answering? Phenolphthalein. Read the question properly. When acids are added to different indicators, acids, if they are added, what are the changes in color? It will become colorless. It will remain colorless, isn't it? Next, Q on the other hand changes orange to red. Methyl orange, which is orange in color, will become red in color. What will happen? Because of methyl orange, isn't it? Litmus paper becomes R to S when acid is treated. That means, what is the answer here? For litmus paper, what will be the change in color for litmus paper? Methyl orange, blue to red. If we have a blue litmus paper, it will become red, isn't it? Next, turmeric, yellow will remain yellow. So the option is A. So this is how you have to approach the questions. So that brings to the end of our demo session.